Hi everyone, welcome to my channel Understood. I am Ben Suresh. Today, the topic which we are going to discuss is thermodynamics and its basic concepts. So, let's start. So, normally in a thermodynamics, normally consider a machine. Now, if you see this machine, we can see that consider a machine means any other machine. You can imagine any machine you want. Consider also now I consider a IC machine first. So in an IC machine, we can see that we know that we have learned the process of IC machine. In IC machine, what normally fuel is being sprayed, and that fuel when it is being compressed, it will be heated. And while that due to that heat energy, this heat energy will be given to the machine, and the machine and that this heat energy produces movement in the piston is being moved, so mechanical energy is being produced. So this is a normal function of machine, and some cases it will be the reverse. While you give the mechanical energy, heat energy is being produced. So like that there are many other interconnection between mechanical energy and heat energy. So similarly we can see in many of the things such as now this is steam in steam turbine, nuclear power plant, internal combustion engine, and this also gas turbine, refrigerator. So here and all you can see that there's an interconnection between mechanical energy and heat energy. So this while we see this interconnection, people are thought that okay, let us be there is an interconnection between them, so why can't it be taken as a subject to study these machines? It can be considered as a subject for study. That subject is known as thermodynamics. By that way we define thermodynamics as a physical science that deals with the relationship and conversion between heat and mechanical energy. So from this, the definition of thermodynamics came. So by this way, the concept of thermodynamics is being evolved. So let's move on to the types of thermodynamics. So types of thermodynamics, normally now we are studying a machine now. As I said, we were studying IC machine like that. So based on what basis you are studying a subject. Now normally in a biology subject, how we learn on a basis of while studying biology, we study microscopic and also macroscopic. In microscopic we can see that we will be learning the cell, parts of the cell. In macroscopic we learn the stem, leaves, flowers. These and all are macroscopic. Even we can see by our eye. So based on what it is on, if it is on microscopic or macroscopic, based on how you study that machine, it is classified into two types. One is classical thermodynamics, another one is statistical thermodynamics. So classical thermodynamics is nothing but here while studying the machine, the effects of many molecules are being considered. That's nothing but, and it also can be sensed by human. Now here you can see that the examples are pressure and temperature. So here you can see that in temperature, in concept of temperature, normally when how heat is produced. Now if there is a substance, by the molecular movement of the substance, many of the molecules, the oscillation of vibration of molecules, the heat is being produced out. So yes, no. Similarly, by that temperature, the concept temperature came place. So this can be sensed by human. So that's why this comes under classical thermodynamics. Similarly, pressure also. And another type is statistical thermodynamics. In this, we study the system or machine. We will be learning it further about system based on the effects of individual molecules. That means one molecule is being taken, and that effect for one molecule you will be having a certain velocity. Like that, there are many other factors. So the effects of individual molecule, any individual molecule is concerned, and this can't be sensed by human. Normally you can see that molecules are of very smaller size, so it can't be sensed by human. So statistical thermodynamics is nothing but studying a system based on the microscopic approach. On basis of microscopic, we are seeing at the individual level, individual molecule level, we are seeing and learning. That is known as statistical thermodynamics. So this can't be sensed by human. So the examples are molecular velocity, mean free path. So these are the two examples. So let's move on to the next one, which is thermodynamic system. So thermodynamic system is nothing, and now we have learned about the machine. In machine we have learned that heat energy and mechanical energy and the conversion. We have learned that. So similarly, thermodynamic system is nothing but a fixed quantity of matter in a particular region where attention is concentrated for analysis of a problem. So it's nothing but, now we have considered a machine. In that machine we have shown that the fuel is being injected and by that heat is being produced. So this fuel, it is kept in a particular region. This it is of a fixed quantity and it is constant and it is in a particular region this fuel is being injected. So that particular region where the action is taken, where we are focusing, there only we are focusing now how the heat is being produced, and from that how mechanical energy is produced. There only our focus, main concentration takes place here, and that is known as the system. And next one is the, normally outside a system we consider what? We consider the surroundings. So from that itself we have found the word. So the outside atmosphere of the system the outside environment of the system, which is known as surroundings, which is nothing but the external factors, such as for compressor. Now if you see a compressor, you'll be having a coolant jacket. Similarly, for many other things, we'll have any other environment such as air, and there are many other things which are outside system, that is known as surroundings. So this system and surroundings are separated by a border which is known as system boundary. So system, surroundings and system boundary. So these all, now we see that the system, surroundings, everything, both of these if we add, even the system boundary if we add, this all consists of the universe. Normally system boundary we don't take, but if we consider system and surrounding, it's equal to the universe. So this is nothing but thermodynamic system. Hope so everyone would have liked and understood the video. So please don't forget to share and subscribe, so that I'll be releasing more videos which will be more helpful for understanding and it will be understood by you. That's why I named the channel as Understood. Okay, so let's see in the next video. Bye bye, take care.